Hello guys, welcome to our channel Shubhada Group of Education Sirsi. You are watching Satish Sir's physics videos for Karnataka CET and NEET. Okay, this is a problem on geometrical optics. When a light wave goes from air into water, the quantity that remains unchanged is its frequency. It's a theoretical question. The answer is frequency. When a ray of light moves from one medium to another medium, its frequency remains the same. Move to the next problem. Okay, a glass slab of thickness 3 centimeter, okay, of refractive index 3 by 2 is placed on an ink mark on a piece of paper. Okay, so here is a piece of paper on which there is a dark mark here. Okay, so the thickness of this is 3 centimeter. Okay, 3 centimeter is there, and for a person looking at the mark at a distance of 5 centimeter from it. Okay, so here it is 3 centimeter, in the sense the person should be remaining 2 centimeter, right? So that totally it is 5 centimeter now. Okay, above it the distance of the mark will appear to be. Okay, so you know that apparent depth must be equal to real depth divided by mu, right? As you mu equal to real depth divided by apparent depth. So therefore I can calculate the value of apparent depth. It is equal to the real depth is how much now here? 3 centimeter divided by mu is how much? It is 3 by 2 here. So it is 2 centimeter. So therefore you can say that the mark is at a distance of, this is the apparent depth now. So therefore mark is at 2 plus 2, that is what? 4 centimeter. So that's the reason why option B is the right answer for this question. The next one is the light travels with a speed of 2 into 10 to the power of 8 meter per second in crown glass of refractive index 1.5. What is the speed of light in dense flint glass of refractive index 1.8? Okay, as we have studied that the refractive index of medium A to refractive index of medium B must be equal to speed in B divided by speed in A, right? As the mu is inversely proportional to speed here. Okay, so now suppose if I take it as light travels, it is in crown glass. That is what, let me take it as mu A, it is what, 1.5 divided by mu B. Okay, so I need to calculate the mu B is also given, right? Mu B is also given, that is what, 1.8 here. That must be equal to, we need to calculate the value of flint glass. So what is the speed here? This is what VB we need to calculate, and VA is how much? 2 into 10 to the power of 8. It implies VB is equal to 1.67 into 10 to the power of 8 meter per second. So option B is the right answer for this question. The next problem says that a transparent cube of 15 centimeter edge contains a small air bubble. Its apparent depth when viewed through opposite face is 6 centimeter, and when viewed through the opposite face is 4 centimeter. Then the refractive index of the material of the cube is. Okay, see, let me draw the ray diagram for this problem now. So here is a cube. Okay, as it is the 15 centimeter, this is what, 15 centimeter now. Okay, assume that somewhere here the bubble is here. Okay, bubble is somewhere here. Okay, now viewed from the first face, this is the first face, is the second face. Now the bubble is appear to be how much? It is at 6 centimeter. At 6 centimeter from the face 2, the bubble is at what? 4 centimeter. It is what? 4 centimeter now. Okay, so let me use the condition now. For first phase, view from the first phase, you know that mu is equal to, assume that the bubble is at a distance of x here, okay, which is at a distance of x now. That is the real depth divided by apparent depth is how much? 6 centimeter. Okay, it's the equation number 1 here. And from view from the second phase, that is what? This distance must be how much? It is 15 minus x now. So that's the reason why mu equal to, mu remains the same, right? The glass is same. So now it is 15 minus x divided by how much it is? It is what? 4 now. Equation number 2. So therefore from equation 1 and 2, I can get mu equal to 15 minus 6x divided by 4. So therefore mu equal to 1.5. Mu equal to 1 point. Option D is the right answer. Okay, the next problem says that on a glass plate, a light wave is incident at an angle of 60 degree. If the reflected ray and refracted waves are mutually perpendicular, the refractive index of the material is. So let me use the ray diagram here, as this is what the angle of incidence here, that is what 60 degree. This is 60 degree, and here must be the refraction of light. It must be the reflection of light now. Okay, as the if the reflected and refracted ray, so if they are perpendicular to one another like this, so at that time actually this must be 60, right? 60. So in the sense it must be 30 now. So therefore let me use the Snell's law. Sine of angle of incidence, that is 60 divided by sine of angle of diffraction 30 degree, must be equal to mu. So therefore mu equal to how much? So therefore mu is equal to root 3. Root 3. Option B is the right answer for this one. Okay, the refractive index of glass is 3/2 and the refractive index of the water is 4/3. If the speed of light in glass is 2 into 10 to the power of 8 meter per second, the speed in water will be the same type of the problem. Let me use this refractive index in glass divided by refractive index of water must be equal to speed in water divided by speed in glass. It implies 3/2 divided by 4/3 equal to VW divided by 2 into 10 to the power of 8. So therefore I will get, therefore VW must be equal to 2.25 into 10 to the power of 8 meter per second. So option B is the right answer for this question. A fish at a depth of 12 centimeter in water is viewed by an observer on the tank of a lake. To what height the image of the fish is raised? This concept is based on apparent rise here. I have discussed in the synopsis apparent rise that must be equal to d into 1 minus 1 by water with respect to air. So it is equal to 12 into 1 minus 3 by 4. Let me take it as 3 by 4 now. As you know that, okay, so this is equal to 3 centimeter. So option D is the right answer for this question. Okay, a ray of light is incident on a transparent glass slab of refractive index 1.62. The reflected and refracted waves are mutually perpendicular to one another. The angle of incidence is. The problem is based on polarization. So this is the polarization by reflection. Brewster's angle mu equal to tan theta p. That is what Brewster's angle or polarizing angle. That is what angle of incidence here. 1.62 equal to tan theta p. It implies theta p equal to tan inverse of 1.62. So that is going to be 58.3 degree. Option A is the right answer for this question. Okay, the wavelength of light in air and some other medium is lambda A and lambda B respectively. The refractive index of the medium is. You know that mu is equal to C divided by V. C by V. Therefore, mu is inversely proportional to what? Lambda as well. So therefore, I can say that mu is equal to lambda A divided by lambda medium here. So lambda B. This is what? Lambda A, lambda M, let me take. Okay, the medium, or lambda B is taken here, but let me take lambda M because option contains M. This must be M. Okay, M here. Lambda A divided by lambda. Option A is the right answer for this question. Okay, so the next problem says that what is the time taken in seconds to cross a glass of thickness 4 millimeter and refractive index 3 by light? As you know that, use this formula T equal to mu into x divided by c. Suppose if you substitute here 3 into 4 milli into the power of minus 3 divided by, it is what, 8 into 10 to the power of 8. Okay, sorry, 3 into 10 to the power of 8, right? Sorry, this is what, 3 into 10 to the power of 8 here, 3 into 10 to the power of 8. So that is going to be 4 into 10 to the power of minus 11 seconds. So option A is the right answer for this question. Okay, The light travels through a glass plate of thickness t and having the refractive index n. If c is the velocity of light in vacuum, the time taken by the light to travel the thickness of the glass is, okay, as you know that speed is equal to distance divided by time here. So therefore time equal to thickness thickness t divided by speed. As you know that mu is equal to c divided by v, that is what speed here. So v equal to c by mu we can take. So therefore I can take time equal to t divided by speed is c divided by mu, that is what mu t divided by c. Option C is the right answer for this question. So thank you very much for watching this video. Please do like our video, share this video with your friends and colleagues to support us. Do subscribe to our channel, and if you have any doubts, make a comment on the comment box so that I can help you with. Wish you all the best for your examinations. Very best of luck.